Namaste. Good afternoon, Arun. Continuation to yesterday's class, we discussed angular bisectors in yesterday's class. If two lines a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0 are the given lines, then the angular bisectors are given by a1x plus b1y plus c1 divided by root over a1 square plus b1 square is equal to plus or minus a2x plus b2y plus c2 divided by root over a2 square plus b2 square. This is what we derived in yesterday's class. So, if you take plus for that angular bisectors, whether it is acute angle bisector or obtuse angle bisector, we don't know. Similarly, if you take minus, whether it is acute angle bisector or obtuse angle bisector, we don't know. For that, we have taken the conditions like a1, a2 plus b1, b2 value, you have to find out. See, cos theta formula is a1, a2 plus b1, b2 divided by root over a1 square plus b1 square into root over a2 square plus b2 square. That is a formula. What is the numerator of cos theta a1, a2 plus b1, b2? So, by finding the value of a1, a2 plus b1, b2, you will be able to understand whether by taking plus, whether you are getting acute angle bisector or obtuse angle bisector. That is the importance of this. And also, the slope of the first line is minus a1 by b1. Slope of the second line is minus a2 by b2. So, this condition is slope dependent. We can say like that. So, if a1, a2 plus b1, b2 value is find out after making c1 and c2 are of the same sign. That is, if c1 is positive, c2 is negative, then multiply the second line throughout with minus and make the constant also positive. So, after expressing c1 and c2 greater than 0, after expressing c1 and c2 greater than 0, then if you find out the value of a1, a2 plus b1, b2, if a1, a2 plus b1, b2 is greater than 0, then by taking minus, you will get acute angle bisector. Then by taking plus, you will get obtuse angle bisector. Similarly, if you get a1, a2 plus b1, b2 less than 0, then by taking plus, you will get acute angle bisector, and by taking minus, you will get obtuse angle bisector. That's about it. And coming to the origin here, that is the angular bisector containing the origin. If you want the angular bisector containing the origin, then you make C1, C2 positive. You make C1, C2 positive. If they are positive, leave it like that. If they are of opposite sign, then make them positive. Both of them must be of the same sign, positive sign. And then take plus for the acute angle, for the angle containing the origin. For the angular bisector containing the origin. For the angular bisector containing the origin. Similarly, if you take any point, for example, x1, y1 is there. We are interested in which region that x1, y1 is lying, whether that x1, y1 is lying in the acute angle region or obtuse angle region. We want to understand that. Then in that case, what we do now, we simply substitute x1, y1 in the first line equation. We substitute second line in the point x1, y1 in the second line equation. Straight away, without altering any c1, c2, something like that. Then if both are positive, then you take plus for the angular bisectors. If both are of opposite sign, then you take minus. That will contain that point x1, y1. So, to avoid the entire confusion here in getting different conditions like acute angle bisector, obtuse angle bisector, and the angular bisector containing the origin and angular bisector containing x1 and like that, I have taken 4 in one problem. All the 4 in one problem. That's what the problem I am showing you to now. This is the problem is for the straight lines 4x plus 3y minus 6 equal to 0 and 5x plus 12y plus 9 equal to 0. Find the equation of the bisector of the acute angle between them. And number 2, bisector of the acute angle between them. Number 3, the bisector of the angle containing the origin. Number 4, bisector of the angle which contains 1, 2. So what are the lines? These are the two lines. And what is to be found out? You have to find out the acute angle bisector first, and then obtuse angle bisector, then the angular bisector containing the origin, then the angular bisector containing 1, 2. So if we work out this problem, 4 problems in one problem, it will be very clear for you now. So let me write the data first. What is the data given? 4x plus 3y minus 6 equals 0, and the second one is 5x plus 12y plus 9 equals 0. It is very clear that for the second line, C2, we can say C2 is equal to 9, which is positive, but the first line, C1 is negative. You have to make it positive. You have to make it positive. What does it mean by making it positive? Multiply throughout with minus, then that will be minus 4x minus 3y plus 6 equal to 0. Minus 4x minus 3y plus 6 equal to 0. And the second one, please, 5x plus 12y plus 9 equal to 0. These are the two lines we have. Now we are interested to find out the acute angle bisector. For that one, find out A1, A2 plus B1, B2 is nothing but minus 20 is minus 36 is less than 0. We are concerned about whether it is positive or negative, that's all. Good evening, Arun. We are concerned about whether it is positive or negative, that's all. So it is negative. So by taking plus, that is opposite sign to this. By taking plus, we will get acute angle bisector. So number 1, acute angle bisector. Okay, is minus 4x minus 3y plus 6 divided by 5. That is root over a square plus b square. Root over a1 square plus b1 square. Because it is negative, we will take positive here. 5x plus 12y plus 9 divided by 13, please. Simplify this. It is minus 52x, and it is 25 minus 25x minus 39y, and it is minus 60y, and the constant is it is 78, and here the constant is 45. So the equation is minus, it is 77x minus 99y plus 28 plus 5, 33 is equal to 0. Divide with 11, please, minus 11. 7x plus 9y minus 3 is equal to 0 is the acute angle bisector. If you want obtuse angle bisector, what is that you have to do? Just make it minus. So number 2, obtuse angle bisector. Obtuse angle bisector is minus 4x minus 3y plus 6 divided by 5 is equal to minus of 5x plus 12y plus 9 divided by 13. We have taken plus for acute angle bisector, we are taking minus for the obtuse angle bisector. The simplification I am writing directly, minus 52, this is minus 25. So minus 25 plus 52, please. It is 27. 27x. It is minus 39. It is minus 60. Minus 60 minus 13. Minus 60 plus 39. Minus 60 plus 39 is 21. 21y, and it is 13, 6, 78. It is minus 45, minus 45, minus 78. Minus 45, minus 78, please. Minus 45, minus 78. It is minus 83, minus 93, minus 103, minus 113. 78, 45. Yes, 113 is equal to 0. Is there any common factor here? No. This is what the obtuse angle bisector is. Number 3, containing the horizon. I must write clearly, bisector containing 0, 0. Bisector containing 0, 0, please. For that one, you have to make C1, C2 positive. Here C1, C2 are positive. C1, C2 are positive. Then take the plus sign for that one. Plus sign we have taken for this. So here this is the acute angle bisector. Contains origin. Number 4, bisector containing bisector containing 1, 2. This I did not discuss yesterday. Bisector containing 1, 2. For that one, very simple. Substitute 1, 2 in the given lines directly without changing the sign. Given lines directly without changing the sign. Let me do that. First line given is 4x plus 3y. So 4 into 1 plus 3 into 2 minus 6. Whether it is positive or negative, positive. And second one, 5 into 1 plus 12 into 2 minus plus 9. It is also positive. Both are positive. If both are positive, then take plus sign for this one. Take plus sign for that one. But the lines you have to take as it is. Therefore, required angular bisector is got by taking plus 4x plus 3y plus 6 divided by 5 is equal to plus 5x plus 12y plus 9 divided by 13. Just say this. Just see this one. If you multiply with minus, then that will be same. Both are same, please. If you multiply with minus. So this contains the point 1, 2. This angular bisector contains point 1, 2. This angular bisector contains horizon. That's what is the concept of angular bisectors. That's what the concept of angular bisector. Let us see the question again. If you see the question, see, this is for the straight lines 4x plus 3y minus 6 equal to 0 and 5x plus 12y plus 9 equal to 0. Find the equation of the bisector of the obtuse angle between them, bisector of the acute angle between them, bisector of the angle which contains origin, bisector of the angle which contains 1, 2. So for the first one, what we did, for the first one, we have first and second, you have to make C1, C2 positive. That is, this is minus 6. We multiply with minus here and we wrote it as minus 3x, minus 4x, minus 3y plus 6 equal to 0. That means we made it positive. And the second one taken directly 5x plus 12y plus 9 equal to 0. And these two, for these two, we got the value of a1, a2 plus b1, b2, a1, a2 plus b1, b2. We have got it to be negative. When it is negative, you will get obtuse angle bisector. When it is negative, you will get obtuse angle bisector by taking minus here. See this one, this is minus here. By taking minus, you will get the obtuse angle bisector. How to get the acute angle bisector? Just exactly opposite side. Acute angle bisector is got by taking plus there. Just see that. Taking plus, you got acute angle bisector. Taking minus, you got obtuse angle bisector. That is done. So this depends on A1, A2 plus B1, B2. That depends on A1, A2 plus B1, B2. Coming to bisector containing the origin here. You have to make both the signs positive. Both the signs of the constant, what I mean to say, C1, C2 positive, we made C1, C2 positive, and if that is positive, take plus sign for the angular bisector containing the origin. Take plus sign means this is a plus sign. This is a plus sign, this contains the origin. Now, for a particular point 1, 2, where in which angular bisector region this 1, 2 lies, then straight away substitute 1, 2 in the given lines directly without altering anything. So I substituted here, I got both positive. Both positive means take plus sign for that one. Take plus sign for that one. If both are of opposite side, then take minus sign for that one. Opposite side, take minus. Same side, take plus. By taking plus, it is nothing but this only. So here, acute angle bisector contains origin. Here, the obtuse angle bisector contains 1, 2. This is about the angular bisectors. Now, the next part of it is the point of intersection of two lines and the set of concurrent lines. Point of intersection of two lines and the set of concurrent lines. The concept of set of concurrent lines is important as far as the objectives are concerned in straight line. Okay, so here, first of all, let us understand the, let me remove this. Okay, now, as far as the point of intersection of two straight lines is concerned, if two lines are non-parallel or non-coincident, then definitely they will intersect each other. How to find the point of intersection? I taught you that in the previous sessions, and here also this shortcut what I am teaching you is very well known to you, but we adjust it according to our convenience to write the point of intersection within one step. That is, if the lines are A1x plus B1y plus C1 equal to 0, A2x plus B2y plus C2 equal to 0, then point of intersection is simply got by, I'm not elaborating this, but you know, in your 10th class itself you have learned elimination method, substitution method, and cross multiplication method. I am taking a cross multiplication method to write the answer directly. In the point of intersection, the denominators of x and y are one and the same. In the point of intersection, the denominators of x and y are one and the same. Then close the constant here. Close the constant and cross multiply a1 b2 minus a2 b1. So this is a1 b2 minus a2 b1. This is a1 b2 minus a2 b1. I'll take an example also, numerical example, and explain to you. So the denominators of both are same. I filled it. Now, coming to the numerator of x, this is x, this is y. Coming to the numerator of x, close x and cross multiply. Close x and cross multiply. b1 c2 minus b2 c1. b1 c2 minus b2 c1. And to get the numerator of y, close y and cross multiply, but from right side but not from left side. Not like this but like this. Only from right side. Remember that. C1a2 minus C2a1. So whatever the cross multiplication method you have learned, if you are comfortable with that one, follow that. If you are comfortable with elimination method, follow that. If you are comfortable with substitution method, follow that. But according to the situation, you have to apply. But this will be very comfortable to write the point of intersection directly. So, example, find point of intersection of, find the point of intersection of 3x plus 2y minus 1 equal to 0, 4x minus 3y plus 2 equal to 0. See how I write within one step now the answer. That is, point of intersection is nothing but x comma y is equal to, within one step I am writing minus 9, minus 8, minus 17. What is that I said? To write the denominator, close the constants and cross multiply minus 9, minus 8, minus 17. To write the numerator of x, close x and cross multiply, close x, 4, minus 3, 1. To get the numerator of y, close y and cross multiply from right side but not from left side. From right side but not from left side. Close y and minus 4, minus 6, minus 10, that's all. That is a point of intersection. Within one step you can write that. It is not only here, in other topics also, solving linear equations in x and y, two linear equations in x and y, wherever you get, you can comfortably make use of this. Even in three-dimensional geometry, 3D, DCs and DRs relations. The relations are given in terms of element, then also you have to make use of the cross multiplication method, and this cross multiplication method is very much useful. So this is about the point of intersection of two lines, and this is the short form of working out, short form of getting the point of intersection. Now, if there are two lines like this, how many points of intersection will be there? If they are non-parallel, one point of intersection will be there. So, through this one point of intersection, if another line is passing through like this, these three are said to be concurrent lines. These three are said to be concurrent lines. So, L1 equal to 0, L2 equal to 0, another line L3 equal to 0. So what is the meaning of concurrent lines? Simply, it is that if you solve any two lines among the three, and if their point of intersection is satisfying the third equation, then we say that those three lines are concurrent. Those three lines are concurrent. Now, if these are the two lines here. This is 1. This is 2. Let me take 3 here. A3x plus B3y plus C3 equal to 0. If 1, 2 and 3 are concurrent, then this point of intersection must satisfy this equation. The point of intersection must satisfy this equation because all these three are intersecting at the same point. All these three are intersecting at the same point. Now, this is A3 into B1C2 minus B2C1 divided by A1B2 minus A2B1 plus B3 into C1A2 minus C2A1 divided by A1B2 minus A2B1 plus C3 is equal to 0. See that, please. So broadly, what is that to be understood? Broadly, what is that to be understood? If three lines are concurrent, if they are given in numericals like this, then if three lines are concurrent, simply solve two lines and you will get the point of intersection. Substitute this point of intersection in the third line. Substitute this point of intersection in the third line. If this point of intersection is satisfying the third line also, then we say that these three lines are concurrent at this point. These three lines are concurrent at this point. That's what I did. I have taken 1, 2, 3 to be concurrent. I solved these two. I got this point of intersection. If this is concurrent, if these two are concurrent with the third one, then this third one must contain this point. That is why I substituted this point in the line equation. And thereby, what is that you get? Just by I am doing all this, you will now understand how it will be converted to the determinant. How it will be converted to the determinant. Plus C3 into A1 B2 minus A2 B1 is equal to 0. Just see that I have taken LCM and wrote the condition. We can say this is a condition for, that is a condition for the concurrent lines. That is a condition for the concurrent lines, please. Okay, now what the mathematician observed, if the condition is properly seen, it is nothing but the expansion of the determinant. It is nothing but the expansion of the determinant. This is like this. More determinant of A1, B1, C1, A2, B2, C2, A3, B3, C3 is equal to 0. This is what you have to understand. How? Just check A3, B3, C3. A3, B3, C3. So the determinant is expanded through the third row. The determinant is expanded through the third row. Just check it out. A3 into B1, C2 minus B2, C1. Just see this. Plus B3 into C1, A2 minus C2, A1. Just see this. Plus C3 into A1, B2 minus A2, B1. That's what it is. So, if three lines are concurrent, 1, 2 and 3, if three lines are concurrent, simply find out the determinant of the coefficients in the same order, A1, B1, C1, A2, B2, C2, A3, B3, C3. If determinant is 0, we say that those three lines are concurrent. Very simple verification, very simple condition to be remembered. And now, coming to the next one is a set of concurrent lines or family of lines. Set of concurrent lines or family of lines is very important. It's very important. Like, I'll continue it here. There is a point of intersection P here for the line L1 equal to 0 and L2 equal to 0. There is a point of intersection. Point of intersection of L1 and L2 is nothing but P here. Point of intersection of L1 and L2 is nothing but P here. So through P, how many lines will be passing through? Through P, how many lines will be passing through? You can just check it out. This is one line. This is another line. This is one more line. This is one more line. How many lines you draw like that? How many lines you draw like that? There will be infinitely many lines passing through a point. If you take a point, from that point, infinitely many lines will be passing through. If you take 2 points, there will be only one line, unique line will be passing through. That's what we learned in the beginning of straight line. To write the equation of a unique line, you require 2 items in the data. Those 2 items may be 2 points, point slope, slope point or point slope, whatever. And slope intercepts, 2 intercepts, and all these are 2 items in the data. So to write a unique line, you need 2 items in the data. But here you have only 1 point here. 1 point. Through 1 point, how many lines will be passing through? Infinitely many lines will be passing through. So mathematically, how do we recognize these lines? Is there any algebraic formula to write the common equation of all these lines? To write the common equation of all these lines, yes, there is, and it is also very important. The given lines are L1 and L2, so you can write the set of concurrent lines using the formula lambda 1 L1 plus lambda 2 L2 equal to 0. Or it is simply, it can be written like this, it will be comfortable, L1 plus lambda L2 equal to 0. So why I am writing both of them? The question may be given in this form or in this form, whatever. Whatever the form is given, you have to recognize. Both are same only, both are same. How both are same? Divide throughout with lambda 1. Divide throughout with lambda 1. What happens? L1 plus lambda 2 by lambda 1. L2 is equal to 0. Lambda 2 by lambda 1 is taken as lambda. Understand? So in place of lambda, lambda 2 by lambda 1. In place of lambda 2 by lambda 1, lambda, both are same. So this will give you set of concurrent lines for different values of lambda. Set of concurrent lines for different values of lambda where lambda belongs to R minus 0. Why minus 0? If this becomes 0, that will be a unique line. L1 equal to 0, you will get only one line. So by varying the values of lambda, for example, lambda, I gave the value as 1. Then L1 plus L2 equal to 0. Lambda, I gave the value as minus 1. Then L1 minus L2 equal to 0. Lambda, I gave the value minus 4. Then L1 minus 4 L2 equal to 0. You'll get one more line. What is the commonality of all these lines? What is the commonality of all these lines? All these lines will be passing through a common point, which is P, which is known to be the point of concurrence. Okay. Now, let me take an example for your better understanding through these two lines only. Because it is very clear we have got the point of intersection of these two lines as minus 1 by 17 plus 10 by 17. Minus 1 by 17 plus 10 by 17 is the point of intersection of these two lines. Now, I am extending this concept for the better understanding of all of you. I am taking this example. Nausea. What I'm doing, I'm just taking this as L1, taking this as L2. In this L1 plus lambda L2, what I'm doing, I'm putting lambda 1 for the better understanding. What is that I'm doing? Let L1 plus 1 into L2 equal to 0. What does it mean? I'm adding these two. If I add these two,
Sir.
Yes, Arun.
Sir, what is lambda and that, sir?
Lambda is said to be parameter, Arun. Lambda is said to be parameter. By varying the values of lambda, you will be getting different lines in this set, in this family. What is the commonality of all this family? This family passes through P. What is P? Point of intersection of L1 equal to 0 and L2 equal to 0. Point of intersection of L1 equal to 0 and L2 equal to 0. So what do we call? Lambda is nothing but the parameter. I hope you understand that.
Yes, sir.
Good. Now, let me write L1 plus 1 into L2 equal to 0. What is that I'm doing? I gave randomly a value lambda 1. Lambda 1, you can give any real number. That's what I wrote. Any real number you can give. Lambda 1. Then add these two. L1 plus L2. What is it? 7x minus 5 plus 1 equal to 0, which is the third line we have got. What is the commonality of these three lines? All these three lines must pass through the point of intersection of these two. Let us check. This is the point of intersection. So it is 7 into minus 1 by 17 minus 10 by 17 plus 1 is equal to minus 7 minus 10 plus 17 is equal to 0. Just check it out. Do you understand what is that happening now? Whatever the lines are made up of these two lines, all those lines will be passing through this point of intersection. All those lines will be passing through the point of intersection of these two, the basic line, these two, nothing but L1, L2. So, if you still have doubt, what I do, I'll vary the value of lambda. I'll put lambda minus 2. Then what happens? Here, this is L1, this is L2. Put lambda minus 2. L1 minus 2 L2 equal to 0. Come on, tell me. Minus 2 L2, no? This is 8. 3 minus 8 minus 5x. And it is 2y minus 2y plus 6y, 8y. And this is minus 1 plus minus 1 minus 4 minus 5 equal to 0. What is that we have learned with regards to the set of concurrent lines or family of lines? It is that all those lines will have the same point of intersection if this set of lines or family of lines is made up of these two lines. So made up of these two lines by giving different values to lambda. I gave lambda minus 2, I have got this line. Now let me check whether this line is passing through this or not. So minus 5 into minus 1 by 17 plus 8 into 10 by 17 minus 5 is equal to 5 plus 80 minus 17, 5 please, 85 is equal to 0. Just see that. Just see that. Here I gave lambda 1, here I gave lambda minus 2, and for all such lines made up of L1 and L2 by giving different values to lambda will be passing through the point of intersection of L1 and L2. Okay, this is called family of lines. Okay, now coming to the set of three concurrent lines. Coming to the set of three concurrent lines. For them also, you can simply say like this. Three lines, important please, important. Lambda 1 L1 plus lambda 2 L2 plus lambda 3 L3 equal to 0 implies L1 comma L2 comma L3 are concurrent. No confusion. Here infinitely many lines. Here we have taken three lines. I'll justify this like this. This is L1 plus L2 equal to 0. One line we have got. What is this line please? L3. Correct, no? How do you get L3? L1 plus L2 is equal to L3. L1 plus L2 is equal to L3, which implies L1 plus L2 minus L3 equal to 0. Just see that. This is not a different condition what I'm saying. This is not a different condition what I'm saying. How it is not different? I'm talking about the third line. Here the third line is got by adding these two. That's what I wrote. L1 plus L2 is equal to L3. Now bring this L3 to the other side. Then L1 plus L2 minus L3 equal to 0. Obviously they are concurrent only because the point of intersection of these two is this. And this is satisfying this equation, and hence those three lines are concurrent. And hence you can write a linear combination of these three lines L1, L2, L3. That's what I wrote. L1 plus L2 minus L3 equal to 0. What is lambda 1 here? 1. What is lambda 2 here? 1. What is lambda 3 here? Minus 1. So, if three lines are there, L1, L2, L3, if you are able to write a linear combination or linear relation between these three such that lambda 1 L1 plus lambda 2 L2 plus lambda 3 L3 is equal to 0, you can confirmedly say that those three lines are concurrent. See, in the theorems, because we are mostly discussing objectives here. I'm not discussing theorems here. See, if you take the next part of it is centers of triangle. Centers of triangle. What are the centers of the triangle? Centroid, circumcenter, orthocenter, incenter. What is centroid? It is a point of concurrence of medians. How many medians are there? Three. Three medians are there. If you find out the equation of first median AD, second median BE, third median CE, if you add these three, you'll get 0. Because they are concurrent at centroid. They're concurrent at centroid. Similarly, what is orthocenter? Orthocenter is a point of concurrence of altitudes. Find out first altitude AD, find out second altitude BE, find out third altitude CF, and add these three. That must be 0 because they are concurrent at the orthocenter. Similarly, circumcenter. Similarly, incenter. So, if three lines are concurrent, then there exists a linear relation such that lambda 1 L1 plus lambda 2 L2 plus lambda 3 L3 is equal to 0. You will get this type of linear relation in vector algebra also. Okay, now that's about the set of concurrent lines, please. That's about the set of concurrent lines. Okay, now let me take an example which at a glance to the problem, you can say the answer. At a glance to the problem, you can say the answer. Let me take such problem. Okay, so I'll take three lines here just to observe. And imagine the answer. This is an example I'm writing here. B minus C into X plus C minus A into Y plus A minus B is equal to 0. C minus A into X plus A minus B into Y plus B minus C is equal to 0. A minus B into X plus C minus A is equal to 0. Are the three lines? Just check. How many lines I have written? 3 lines I have written. 3 lines I have written. Now, let me say this line as L1, this line as L2, this line as L3. Check it out. L1 plus L2 plus L3 equal to 0. Therefore, they are concurrent. Check it out. Sum them. Plus B minus B plus C minus C minus A plus A cancel. Plus C minus C plus B minus B plus A minus A, and here also everything. Adding them, you are getting 0. That means you are getting lambda 1 1, lambda 2 1, lambda 3 1, and hence you will get this type of relation 1 into L1 plus 1 into L2 plus 1 into L3 equal to 0. You cannot make an attempt to solve the first 2 lines and substituting in the third equation like we did previously, because they are not numericals there. They are not numbers there. So it goes very difficult. So at a glance, you have to understand. Sum of the 3 lines is 0, and hence they are concurrent. Okay. So this is about the set of concurrent lines. Anyway, we'll be working out the problem on that one. Okay. Now, coming to the next part of it, the centers of the triangles. Centers of the triangles, we already discussed in the introductory part The centroid, there is no problem at all. You have a straight formula for that one. X1 plus A plus B plus C by 3. Average of three vertices. Average of 3 vertices. That is A plus B plus C by 3. Is a centroid. Orthocenter. Then only I said it is to be solved using straight line. Circumcenter. Then only I said it is to be solved using straight line. And in center, of course, you have the formula. AX1 plus BX2 plus CX3 by A plus B plus C. AY1 plus BY2 plus C by 3 by A plus B plus C for in center. And X centers, of course, that depends on whether it is opposite to vertex A or whether it is opposite to vertex B or whether it is opposite to vertex C. If it is opposite to vertex A, then A will be replaced with minus A. If it is opposite to vertex B, then B will be replaced with minus B. If it is opposite to vertex C, then C will be replaced with minus C. That's all. The in-center formula and X-center formula, the difference is that only, nothing other than that. So, let us now take a problem. Because we have already taken the definition of all these centers in the introductory part only. I'm taking up the problems now. Okay, so let me take the problems related to that. Let us write the data now. First one I'm taking. Let us see the options later. If the equations of the three sides of a triangle are x plus y is equal to 1, let me write the data. What is the first line? 3 lines are given there. Three lines are given there, and the orthocenter of the triangle lies on the line. Obviously, orthocenter always lies on the altitude. Orthocenter always lies on the altitude. It is inevitable. Everyone knows that. So he gave the altitude equation options. Let me write. First line, please. X plus y minus 1 equal to 0. Second line, please. 3x plus 5y minus 2 equal to 0. Third line, x minus y equal to 0. Just observe these two. Both are perpendicular to each other. Y, its slope is minus 1. Its slope is plus 1. The product of the slopes is minus 1. So it forms a right angle triangle. And hence, in a right angle triangle, the vertex containing the right angle is nothing but the orthocenter. The vertex containing the right angle is nothing but the orthocenter. This is nothing but the orthocenter. Symbolically, what I do, I'm using HE for orthocenter because O stands for the horizon there. General notation. Whatever we say, that will be good. So H is a orthocenter. So if you solve them, now you don't need to apply the short form what I taught you because they're very simple. Now we go for elimination method. Plus y minus y getting cancelled. 2x equal to 1, x equal to 1 by 2. And x equal to 1 by 2, y is also 1 by 2. This is nothing but H here. H is nothing but the orthocenter because it is a right angle triangle. So now lies on the line he is saying. Just check the options. 5x minus 3y is equal to 2. 5x minus 3y is equal to 2. Option A. 5 by 2 minus 3 by 2 is not equal to 2. It is 1. So it is not the answer. Option B. For 3x minus 5y. 3 by 2 minus 5 by 2 is equal to 1. No, it is equal to minus 1 here. C. 2x minus 3y. 2x minus 3y. 2 by 2 minus 3 by 2 is equal to 1. No, it is equal to minus 1 by 2 here. It is not also correct. So obviously you need not have to go for D. D must be true. 5 by 2 minus 3 by 2 is equal to 1. That is answer. So the orthocenter lies on the line. The orthocenter lies on the line 5x minus 3y is equal to 1. That's what the question is. That's what the question. Okay, now let us see the next question, please. Let us see the next question. Circumcenter of the triangle formed by. Circumcenter of the triangle formed by. How many lines are given? The points are not given. If the points are given, you'll have to find out the, in this case, altitude. In circumcenter case, perpendicular bisectors. Now here, you have to find out the circumcenter of the triangle. You have to find out the circumcenter of the triangle. What are the equations given? One is x plus y is equal to 0. And the other one is 2x plus y plus 5 equal to 0. And the third one is x minus y minus 2 equal to 0. You have to find out the circumcenter of this. First of all, what is the circumcenter? First of all, what is the circumcenter? Circumcenter is the point of concurrence of perpendicular bisector. Circumcenter is the point of concurrence of perpendicular bisectors. So, to get the circumcenter, you need at least two perpendicular bisectors equation. You need at least two perpendicular bisectors equation. So here, let me say, this is L1, this is L2, this is L3. L1, L2, L3, let me say this as A, B, C. L1 is equal to 0, L2 equal to 0, L3 equal to 0. What is A here? What is A? Now solve this. 1 minus 2. The short form now use it. And it is 5. And it is minus 5. So it is minus 5, 5. Okay, now let me find out one perpendicular bisector and verify the answer. If single answer is there, that will be the answer. If double answer is there, you have to go for the second perpendicular bisector. So, what is L3 here? How to write the perpendicular bisector to this? Okay. I must have another also. Let me solve L1 and L3. L1 and L3. This one, L1 and L3, please. What is minus 2 minus 1? This is minus 2 plus 5, 3. This is 5 plus 4, 9. So it is minus 1 comma minus 3. What is the midpoint of this? A and B. What is the midpoint of A and B, please? Midpoint, please. Minus 5 minus 1 by 2. 5 minus 3 by 2 minus 3 by. I need the perpendicular bisector. So, perpendicular bisector of AB, please. Perpendicular bisector of AB. What is AB here? L1. So it will be in the form of x minus y. Perpendicular, no? Reverse the coefficients and change the sign in between. Reverse the coefficients and change the sign in between. If you want to write the perpendicular of this, write this coefficient here and this coefficient here and change the sign. Then it will be x minus 2y is equal to k. So x minus y is equal to, it passes through this point because it's a perpendicular bisector. Minus 3 minus 1 minus 4. This is one perpendicular bisector. After this, you have to find out second perpendicular bisector. But I'm not going for that. I'm just verifying the options. First option, please. Verify. First option, minus 2 minus 1. No, that's not the answer. Second option, minus 3 minus 1 is equal to minus 4. It should be the answer. Let us not leave. Third one, minus 4 minus 3, not equal to minus 4. It is not the answer. Fourth one is minus 1 minus 3. Minus 1 plus 3 is not equal to minus 4. So only one answer. So the option 2 is the correct answer to find out the circumcenter. Here I did not work out the entire problem. Here I did not work out the entire problem, but what I did verification. Just follow that carefully. Circumcenter is the point of concurrence of perpendicular bisectors. Circumcenter is the point of concurrence of perpendicular bisectors. So if you know one perpendicular bisector, in the options, if you have circumcenter, take that perpendicular bisector and verify the options to lie on this one, because the circumcenter always lies on the perpendicular bisector. That's what I did. I got the answer. Okay. Now let me go to the next question. The incenter of the triangle. See that, please. Just if you observe carefully, let me revise about the incenter completely. Incenter is the point of concurrence of internal angular bisectors. So incenter is a point of concurrence of internal angular bisectors, and for that one, in the introduction of coordinate geometry, in the beginning lectures, I have derived the formula for incenter, because incenter has good number of properties. What are they? Number one, the internal angular bisector divides the internal angular bisector, this one, internal angular bisector divides its opposite side in the ratio of these two sides. That is, if it is C, if it is B, then this internal angular bisector divides the opposite side in the ratio of C is to B. This is you have very much in your lower classes as a theorem. The internal angular bisector of a triangle divides its opposite side in the ratio of its sides. Similarly, the incenter divides the internal angular bisector in the ratio of B plus C is to A. B plus C is to A. What is B? Length of AC. What is C? Length of AB. What is A? Length of BC. So B plus C is to A. And by applying those conditions, we get the incenter formula which is a lengthy formula, ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. Okay. Now, if it is a x center, opposite to the vertex A, replace A with minus A. If it is a x center opposite to the vertex B, replace B with minus B. If it is a x center opposite to the vertex C, then replace C with minus C. If you want more details about that, just see in this series, I did the second video on this one. Second video on this one, the in center, I derived it and explained it at length. Now here, in this problem, see 3 lines are given and he needs alpha, beta. Just observe. The in center of the triangle formed by the lines 3x plus 4y is equal to 10. And the second one, 5x plus 12y is equal to 26. Third one, 7x plus 24y is equal to 50. In fact, if you want to apply the formula there, what I said now, in fact, if you want to apply the formula there, what I said now, ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c, what is that to be done? You have to solve 1 and 2 to get x1, y1. You have to solve 1 and 3 to get x2, y2. You have to solve 2 and 3 to get x3, y3. After getting those coordinates, you have to find the lengths of the sides. That is AB length, BC length, CA length, and thereby you will get small a, small b, small c. Then you have to apply the formula. See the length of the problem. See the length of the problem. It is very lengthy. So, in the objective, such questions generally will not be given. Even if it is advanced also, in the advanced, more conceptual problems will be there, but this type of lengthy problems without any technique will not be given. So if it is given in the objectives, definitely there will be a technique. What is the property he used here? Just see this carefully. See, if there is a triangle, I'll make it like this. This is the triangle and this is the in circle. The property with regards to in center, is that in center is equidistant from the sides. Whatever the distance is here, this is termed as small r, which is in radius, we call it as in radius. This is also small r. This is also small r. Just see that. What is the difference between this and circumcircle? Circumcircle will be circumscribing the triangle. In that case, this is I, that is S. Excuse me. SA is equal to SB is equal to SC. This is said to be capital R. This I posted a small video. How to find out the circumcenter. Small video, you can go to that. See the difference? It is circumscribing the triangle. It is inscribed in the triangle. So the triangle, the circle, if it is inscribed, the in center is equidistant from the sides and the circumcenter is equidistant from the vertices. Whatever the center of the circle is there, SA is equal to SB is equal to SC. Find the difference. For circumcenter, SA is equal to SB is equal to SC. For in center, ID is equal to IE is equal to IF. Okay, now here if you take this, what happens? Let me check. you must form the idea. There is no other go. If you want to solve it now, it will become a more than a long answer question. More than a long answer question. Mod c by root a square plus b square. 10 by 5, 2. Mod c by root a square plus b square. 26 by 13, 2. Mod c by root a square plus b square. 50 by 25, 50 by 25, 2. So, from 0, 0, this is at a distance of 2. From 0, 0,
Sir.
this is at a distance of 2. Yes, Arun.
Sir, I can't see what you are writing, sir. That question is hiding that.
Sorry. That's good, Arun. That's good. You have reminded me. Good. I'm removing it.
Okay, sir.
Yes. Very good, Arun. So, I repeat this. These are the 3 lines given, 1, 2, 3. These are forming a triangle. If you want to find out the incenter, if you want to apply the formula, that will become more than a long answer question. More than a long answer question, because you have to find out all the 3 vertices ABC, and you have to find out the lengths of the sides, and then only you can apply the formula. If it is to be done, it is very, very lengthy. But there should be some technique here. What is the technique? If you take incenter, incenter is always equidistant from the vertices. Incenter is always equidistant from the vertices. Obviously, it happens, you know. If it is not equal, it won't touch all the 3 sides. Circle is touching all the 3 sides. Circle is touching all the 3 sides means these are the 2 tangents. These are the 2 tangents. These are the 2 tangents. It happens only when the perpendicular distance from the incenter to the sides are equal. Then only it touches all the 3 sides. Similarly, what is the circumcenter? Circumcenter is a center of that circle which circumscribes the triangle. That means it is passing through ABC. And hence, it is SA is equal to SB is equal to SC, where S is the circumcenter. That is different. It is equidistant from the vertices. It is equidistant from the sides. Remember, incenter is equidistant from the sides. Circumcenter is equidistant from the vertices. Remember that. Now, if you observe carefully, mod c by root a square plus b square for this, mod c by root a square plus b square for this, mod c by root a square plus b square for this is same. Just to see that perpendicular distance from 0, 0 to 1, 2, 3. Each is equal to. What is the perpendicular distance from 0, 0? Mod c by root a square plus b square. So 10 by 5. 2. Mod c by root a square plus b square. 26 by 25. 26 by 13, 5 square plus 12 square. 5 square plus 12 square is nothing but 169 under root is 13. So 26 by 13 again 2. What is the formula for this? Mod c by root over a square plus b square. Perpendicular distance from origin to the line. Similarly, if you write this mod c 50 by root over 625. 50 by root 625 means 50 by 25, it is also 2. So this is all equidistant from the origin. All the sides are equidistant from the origin. And hence we can say that in center is equal to 0, 0. In center is equal to 0, 0, please. So he gave it as alpha, beta. What is alpha plus beta? Obviously 0. That is what the question. There is a twist in the question. It is not a direct question unless you get the idea of this property that in center is equidistant from the sides. You cannot solve this problem. If you start solving the problem in the regular method, I said, It is more than a long answer question. Let us now check the option. See this one, please. Alpha comma beta is 0, 0. Alpha plus beta is equal to 0 plus 0, 0 answer. So this is what? This is what the three centers. Centroid, I'm not doing any question on that one because centroid is very well known to you. It's also simple. You learned it in your 10th class itself. So this is the problem of in-center. And for in-center, there is a short formula. Short formula in a special case. In a special case. That also I'll discuss. That also I'll discuss. See, if there is a triangle, formed by its two sides, as x and y axis by another line, this is O 0 0, and this line equation is x by a plus y by b is equal to 1. This is a comma 0, this is 0 comma b. Obviously this length becomes a, this length becomes b, this length becomes root over a square plus b square. In center in the special case. What do you mean to say? In center in the special case. What is the special case there? Unlike x1, y1, x2, y2, x3, y3, you have three vertices 0, 0, a 0, 0, b. 0, 0, a 0, 0, b. Then we will apply the same formula. Whatever the formula we have learned, whatever the formula we have, we'll get the same formula, but you will get it in the simplified form. Very simplified form like this. In center is AB by a plus b plus root over a square plus b square, comma AB by a plus b plus root over a square plus b square. Just say it out. X and y coordinates will be same for this. X and y coordinates will be same for this. Why? You will get this in your next coming topic, circles. If a circle is touching both the axes, if the circle is touching both the axes, like this, then what happens? This length will be equal. That is, the x coordinate of the center and y coordinate of the center must be equal. X coordinate of the center and y coordinate of the center must be equal. Then only it touches both the axes. That further you will be learning in circles. That is the reason why you will get both the coordinates same. This is a formula, please. This is a formula. I'll take a problem to write the in center. Find in center. Of the triangle formed by, find the in center of the triangle formed by 7x plus 24y, and I'm making a little twist in the question. 7x minus 24y is equal to 50. This is the question. What is the line I have taken? Not 7x plus 24y. I have taken 7x minus 24y. The reason you'll understand. Now, what is the in center for this? See, what I do, I'll take, because you'll get a fraction here. You'll get A fraction, because x-intercept is 50 by 7, y-intercept is minus 24 by 50. So let me change the line. You can do for this also, but it is fractions, that is why it will take time. Let me take a simple problem like this. That is 3x plus 4y is equal to 3 by 5. I have taken like this. 5x plus 10y is equal to 50. Now I have to convert this to this form, intercept form. Convert it to that form. X by 10 plus y by 5 is equal to 1. Therefore, in center, I am twisting the problem here just to make you understand what happens if there is minus like this. I am taking 5x minus 10y is equal to 50. Now I is, apply the same formula, 10 into 5 a into b by 10 plus 5 plus root over 10 square plus 5 square root 125. And it is also same 15 plus 5 root 5. If you simplify this, if you can take 5 common here, 5 gets cancelled, 10 by 3 plus root 5. It is also 10 by 3 plus root 5. Just understand that. What is the twist I have taken here? What is the twist I want to tell you here in this question? If you remember the formula like this, and if you substitute like this, you will get the answer like this, because this is A, this is B, but here it is minus. This line will have positive x-intercept and negative y-intercept. This line will have positive x-intercept and negative y-intercept like this. This is x-axis. The line will be like this. When the line is like this, this is O, this is A, this is B, and hence the in-center lies in the fourth quadrant, please. Q4. In-center lies in the fourth quadrant. When in-center lies in the fourth quadrant, X is positive, no problem, but Y must be negative. X is positive, no problem, but Y must be negative. That's what you have to remember. So that's the reason why we make a small alteration to this problem like this, to the formula like this. A modulus of B, mod A B. And of course, this is mod A, this is distance, please. Mod A plus mod B, mod A plus mod B. What happens here? If B is negative, you have to make, you have to take it minus B then. If A is negative, then you have to take minus A there. You have to take minus A there. So here, if you apply, A is 10 and B is minus 5. A is 10 and B is minus 5. Let us make it in this way. This is, the formula is mod AB, A mod B. Just see this. Now A is positive, no problem. Take plus A only. And B as it is taken 5. And it is A mod B. A is positive, taken as it is. But B is negative, no? B is negative. That is why you have to write minus B there. This is minus 5. So that becomes obviously minus 10. So this is the formula. This is a short form for in center. This is a short form for in center. Okay. So these are the centers of the triangle. These are the centers of the triangle, please. Okay. Now let us work out some problems. Let us work out some problems on these concepts. Okay. Right. Hello. First of all, let me finish this problem. It's a previous question and interesting. Interesting question. Common sense point. Good question. The number of integral points, exactly in the interior of the triangle with vertices of the triangle 0, 0, 0, 21, 21 comma 0. First of all, understanding the question is very, very important in this case. So, let me take a more detailed diagram before solving this problem. More detailed diagram before solving this problem. What is the meaning of integral points? Integral points are nothing but just a moment please. What are the integral points? If x coordinate is integer and y coordinate is also integer, they are said to be integral points, please. They are said to be integral points. Understand that? Okay. Now in this case, let us find out the integral points strictly interior to the triangle. Strictly interior to the triangle. Let me explain that. See, this is x-axis because he gave 21 comma 0 there. This is y-axis because he gave 0 comma 21 and he mentioned 0, 0 also. So what are the coordinates now of this triangle? Are nothing but this is 0 comma 0 and this is 21 comma 0 and this is 0 comma 21. Now the triangle formed The triangle formed is this one. It is an isosceles triangle because opposite sides are equal here. This is 21, that is 21. Now what he means to say, he wants integral points here. What are the integral points? For example, I have taken a line here, x equal to 1. This is x is equal to 1. Okay. Now, I have taken another line. Y is equal to 1. I have taken one more line. Y is equal to 2. I have taken one more line. Y is equal to 3. I have taken one more line. Y is equal to 20. I have taken another line. Y is equal to 19. I have taken one more line. Y is equal to 18. Just for your better understanding, I am doing this. I'll take one more line which is x is equal to 2. I'll take one more line which is x is equal to 3. I'll take one more line which is x is equal to 20. This is x is equal to 19. This is x is equal to 18. Okay. Now what he needs, I'll write some point, then you will better understand it. I'll write some points there. This is 1 point, 1 comma 1. This is 1 comma 1. What is this point? 1 comma 2. What is this point? 1 comma 3. What is this point? 1 comma 20, which we don't need because it is lying on the triangle, but we need the vertices which are strictly inside the triangle. Just check the question. I'll show you the question once. The number of integral points means both the coordinates should be integers exactly in the interior of the triangle. In the interior of the triangle, that's what you have to understand. In the interior of the triangle it must lie. So 1 comma 20 not taken. And this, it is 1 comma 90. It is taken, it is inside. It is 1 comma 18 taken. So how many points are there on this line? 1, 2, 3, so on up to 19. 19 points are there. 19 in this case for x equal to 1. For x equal to 1, these are 19. I'll change the color. For x equal to 1, these are 19. For x equal to 2, this will be 18. For x equal to 3, this will be 17. For x is equal to, this is 21, this is 20, this is 19, this is 18. There will be 2. It will be 2, and here it is 1. So, final answer is 19 plus 18 plus 17 plus and so on plus 2 plus 1, sum of the first 19 natural numbers. N into n plus 1 upon 2 is nothing but 190. That is the answer, please. That is the answer. Just check it out. Okay. Now, algebraically, how do we proceed? That is also important. So, drawing this diagram and writing the answer, it will take more time. Like this, it will take more time, and everyone can do that. But learning, we have learned algebra. What is the advantage of learning algebra? You will understand now. Let us see how that solution is given. Let us see how that solution is given. Just see that. See, always the line equation here is x plus y is equal to 21. Line equation, because x intercept 21, y intercept 21, and it will be x plus y is equal to 21. Then if the point lies on it, no, then the sum of these will be 21. But if the point lies inside, no, if it lies on this side, x equal to 0, y equal to 0. But your point must lie inside, and hence your x plus y must be less than 21. X plus y must be less than 21. Then obviously x is less than 21 minus y, or y is less than 21 minus x, whatever. First of all, you understand x plus y less than 21 or not? Yes. X plus y less than 21 or not? Yes, because they must lie inside. The point must lie inside. Now, if I write x is equal to 1, let me say, implies your y must be less than 20. Y must be less than 20 means y must take the values 1, 2, 3, so on up to 19. That's what I have shown in the diagram. If x is equal to 2, no, your y must be less than 19. And that's what I have shown in the diagram. Y is equal to 1, 2, 3, so on up to 18. If x is equal to 19, your y is less than 2. That means y is equal to 1. This is the summation. That's what I have shown. 19, 18, 17, so on up to 1 you will get. So total number of points will be 190. Total number of points will be 190. This is what you have to understand with regards to this problem. In the next session, we'll be doing the problems on set of concurrent lines and some problems related to centers of the triangle, and all the previous questions and miscellaneous questions we will be working out in the next session. See you in the next session. Have a good day. Namaste.